Great. Today we're going to talk about position time graphs, and we're going to talk about different shapes on the position time graphs and what that means for the objects that they represent. We're going to talk about the velocity and acceleration time graphs and how to figure things out. So first, we're going to start with a red line. And this red line, you can see the y-axis is represented by position, which in this case is x. It's position along the x-axis. And the x-axis has time. So for this red line, the object has the same position at all times. It's not going anywhere. It's a stationary object. Then we get to this orange line. And the orange line starts near the origin, starts near where x is 0. And continuously moves away from the origin. And so for every equal interval of time, it goes the same distance away. And that's pretty much what that represents. What yellow represents is a line an object that starts at the same position as the red object, but it continuously moves closer and closer to 0, closer and closer to the origin. And then actually goes below 0, it gets into a negative position, but it's continuously changing. It just has a negative slope. This green line, what's happening with the green line, is it starts out with a 0 slope near the origin. And the slope is continually increasing. We call that a quadratic or a parabola. Now, what we're also going to have for a parabola is this purple line, which starts out with a positive slope. It's moving away from the origin. The slope keeps decreasing. It gets to 0 at the highest point. And then the slope goes negative as it falls back to the origin. So what's happening here? If you remember back from algebra, what you could find is that slope is equal to rise over run. Rise being the change in the y-axis, run being the change in the x-axis. So in this case, slope is delta x over delta y, or velocity. So the slope on a position time graph is equal to velocity. Now the red line has a slope of 0, so the velocity is 0. The orange line has a slope greater than 0, and it's constant. It's not changing. The slope doesn't change. So the velocity is greater than 0 and constant. The yellow line, it has a constant negative slope, less than 0. The green line, what's happening there? The green line starts at 0, and it keeps getting larger and larger. It's increasing. The slope is increasing. Velocity is doing the same thing. Then we get to purple. What's going on with that purple line? It starts with a very high positive slope, and the slope gets lower and lower and lower and gets to 0. And then the slope actually goes negative until the object gets back to its initial position. So it's initially positive. It continuously decreases. So it goes to 0 and then goes negative. So what does this mean? Slope is equal to velocity, so we'll make a velocity time graph and an acceleration time graph. And on velocity time, you'll see that red has 0 velocity. Orange has a positive velocity that's constant, and yellow has a negative constant velocity. And purple starts with a positive velocity, and where the line goes horizontal, the velocity is 0, and then it gets more and more negative. So what we've got is red, orange, and yellow. They all have a constant velocity. Red is 0, orange is positive, and yellow is negative, but they're constant velocities. Green, velocity keeps increasing. And then what happens with purple? Starts with positive velocity, it keeps constantly decreasing to 0 and then actually goes negative. So what we're going to do is talk about acceleration. Turns out that where slope is rise over run on a position time graph, what that means is slope is equal to velocity. But if we do the same thing on a velocity time graph, on our second graph down, slope is equal to acceleration. So what's happening there? If we look, red, orange, and yellow have a constant velocity, so they have 0 acceleration. Green has an increasing velocity or positive constant acceleration. And purple has a decreasing velocity. And it starts positive, goes to 0, and goes negative. So purple has a negative acceleration. It starts near the origin, goes up away from the origin, and then comes back to the origin. If we were to throw an object in the air, this is what it would look like. It would start with a positive velocity. The velocity gets lower and lower and lower. At the highest point, represented by the dotted line, it goes to 0, and then the velocity goes negative as it falls back down. So for this purple line, if our displacement is in the vertical direction, this represents a projectile or an object thrown in the air, gets to a maximum height, and then comes back down and is caught at the same height where it was thrown. And the acceleration would be equal to negative 9.8 meters per second squared. I hope this helps you understand the position time, velocity time, and acceleration time. Thank you for visiting and listening.